빅데이터 세션 강연으로 린 AI 공동설립자이신 장응윈 최고 비즈니스 책임자님의 데이터 처리 기술을 통한 AI 도입 민주화 및 가속화를 주제로 한 강연을 들어보겠습니다. 화면으로 만나보시겠습니다.
Hello, ladies and gentlemen. Today I'd like to talk about data quality for machine learning trainings. So my name is Zhang. I am currently CEO at Ling AI. We are a company that provides a service and infrastructure for company to process or rather annotate data for AI and machine learning applications. So as you already very familiar, data is key for AI development. And this is even more crucial because nowadays people are starting to develop this so-called continuous development circle of machine learning models. So we start with data collections, annotate data, train model, deploy model in the actual applications, whether cloud or edge, and continuously monitor it. During which they will also start to collect data again. And this is the whole circle. So what we observe in the industry is that people would typically have this flow setup. They have the tools and they have the process. So very periodically, they would collect the data again and annotate the data and train the model again because of some degrading model performance, what they call model drift. So yeah, needless to say, data is very crucial in this process. But the challenge here is that to process data with quality is not easy because we have identified three reasons for this. First is no requirements feedback loop, and the second is disruptive requirement changes, and third is loose data quality review process. I'll go in details each of these points right now. So if you take a look at this example, you can see that this is a horse carriage. And let's say if you are machine learning engineers, you're tasked to train a model for an autonomous car applications, right? And when you create a requirement, you probably don't even think about having this class in your requirements. And not having this class in these requirements is actually an issue because we realize that when we actually do execute the task, there are very strange cases like this, and the annotator would make assumptions. For example, some would classify this as car, some would classify this as truck, and some would classify this as animals, which might not be the case. So in cases like this, we would typically recommend the annotator to reach out, or rather to note this image and move on. So just to give you an example. And second one is the requirements can be very vague. For example, in this case, the annotator is tasked to draw all the vehicles in this image. And as you can see, that vehicle all the way down to the street, right over the, right near the horizon. And the object can be pretty small. And in this case, right, some annotator might just argue that, hey, I don't think I should annotate this because I can't see it very clearly. And other annotator might argue like, I think I should annotate all this because I think it's important for me to annotate everything. Yeah. So in cases where the definition of what annotation should annotate is not clear, people are likely to make assumptions. And people would say, and interestingly, we observed that when the annotator reach out to machine learning engineers to ask for instruction, the engineer would say, just try to draw large object, big one. You don't need to draw a small one. And the annotator would ask, hey, how small is small? How big is big? So these are the issues to be addressed. Another example would be, some annotator would just draw the whole object as truck and ignore the driver inside. And some annotator was think, hey, I think there's a driver inside. I think I should draw it. So there's an inconsistency in people's understanding, and this is really an issue that we're observing, which affects the data quality. So the second one is disruptive requirement changes. That's the second issue. So as you already know, right, the labeler, they will learn requirements and they become some sort of labeling expert in that specific task. And typically in a project, right, there can be tens or hundreds or even thousands of annotators working together simultaneously, and everyone have different understanding of the requirements and results in different level of expertise for that task. So the challenge here is not only they have different understanding of the same requirements, but when there's new requirement, for example, in the previous example, right, there's a horse garage, and then the engineer just decided, hey, I want to add this class into my requirements. And this can cause confusion for annotators who already learned how to annotate. Yeah. So an example would be the old requirements, label four-wheeler as vehicles. So, and the new requirement would be label car and truck separately. So for people who know the requirements, they would annotate as car and truck. But people who do not know the requirements update, which is everything is vehicle. So the challenge is we're working together with hundreds of people, right? So how do we ensure that everybody is updated, is informed when we have requirements update, which likely to happen during the annotation process and not before the annotation process. So this is really an operational challenge and to be addressed. The third one will be loose data quality review process. So what we observe typically right now is what people would do is people would assume that a group of people would understand the requirement the best. For example, the engineers, machine learning engineers, data scientists, who actually define the requirements. We assume that they understand the requirement best. Then they will be the one who review the whole data set. So for example, let's say the annotator, after annotating 100,000 images, they would sample 10% images, 10% of the samples, and check them. Yeah. And interestingly, we've seen that a lot of people just choose this number 10% very randomly. I don't know, 10 is a magic number, but people tend to choose that number. Yeah. And needless to say, even though they are the people who create the requirement, there's still chances of making errors, and silly errors like ignoring a car as a truck or something along that line. We human make mistakes. So even the expert, basically the so-called reviewer, we also make mistakes. So how do we minimize the errors? Yeah. So there are some tips to ensure data quality for ML trainings. So for the first issue is requirement feedback loop. So we observe that we should always create requirements with example, and in fact we should create something called example log. So for example, for one class like car, right, we should give various example what the car should look like, and for all the cases like truck, right, what the truck should look like, and we put that as part of the requirement. And note that this requirement is just static. It should be updated over time. So the annotation tool itself should be able to support the annotator to skip the confusing examples and report that confusing example to the supervisors. In this case, can be a person who understands the requirement very deeply. So the person would judge and update the new requirement with new sample examples. Yeah, and in that sense, right, the requirements will be continuously updated, and not only in the sense that it updated by words, but it also have examples. So the annotator become the the agents to helps the project manager to update the requirements by giving the feedback. Yeah. The second one is disruptive requirement changes. So whenever there's new requirements, right, naturally we expect that people would not carry on their tasks with the old requirements. So we should have the tools, the annotation tools, or the annotation process should have a protocol to stop doing the new task and make sure that the annotators or the people who are doing the task, the laborer who are doing the task, can master the new requirements. Yeah, and that's very crucial because otherwise they will carry on the task and create systematic errors. Yeah, so they block. So there should be a way to block them from doing their current task and notifying them with the new, requirements. And we should have a way to make sure that they have the consistent understanding of the requirements, the new requirements. So benchmark and consensus method might come into play. So we might get more people to do work on the same task together and compare their results. So for example, if let's say two person working on the same task together and they result in different low consistency, for example, in the left side image, then that would be a bad indication of consistency and their level of master the requirements. But let's say if the annotators they can perform at a very high consistency level, for example, in the right side, they both annotate truck as truck, car as car, and the overlapping of their boxes are quite okay, then we can qualify them as as good annotators. So so the tools to annotate should have some sort of ability for people to upload sample images and for annotator to attempt. And after attempt already, the tool should be able to qualify whether that person have mastered the requirements by giving the correct annotations. Yeah. Or the tool should be able to, allows multiple people to attempt the same image and then get a consensus of it on, how consistent they are in terms of output. Yeah. And from there, we can also deduce the quality of the understanding of their requirements. And last but not least, loose data quality review process. We have come up with something during our process of doing annotation. We realized that for simple tasks like classification, right, the model can actually do quite well. For example, if you give a model of a piece of image of a horse only, it will be able to predict it as a horse or a car. But human, even though we are very intelligent, right, we sometimes make mistakes, silly mistakes. So I have seen people who label basically like road as car or vice versa. So this is kind of mistake that shouldn't have made. And if we leverage the power of models, using a lot of models, so some model to check the common class, so so the annotation tool should enables the team leader to set up the test. For example, for this specific class, run prediction on it and compare with the humans labels. And this very high inconsistency, then send this image to the reviewer to check. So right now we are not just randomly checking 10% anymore, but rather we are using a more guided method, using the model to check first, and then rank the image based on the uncertainty or the inconsistency with the model predictions, and then let the reviewer to review. Is that also subject to a chance of maybe the model are also making systematic errors? So there has to be a balance here. Yeah, and of course we figure out that there are rule-based unit tests to check annotations, right? So similar to the way we do software development, we can also write unit tests to check the format, to check the basically some of the easily, clearly defined features of the data sets. Take, for example, this is for example, let's say the human annotate this as, as you can see, right, the person draw the box quite accurately, but for some reason the person just annotated it as cat. And this, if we just keep it like this, right, it will bring out the data quality overall. But very likely that if we have a model that knows how to pick rabbit and has been trained on sufficient data set, it likely to output rabbit. And if 3 of the model consistently give this result, then we should send, and this result is very different from the human annotation, then we should send this to for the reviewer to check. or rather prioritizes sample to be checked. And an example of unit test would be zebra crossing should not overlap with pedestrians. Interestingly, when annotators draw this kind of annotation, right, they would typically by my misunderstanding of requirements or because of the requirements not clear, they would have some sort of overlapping between the pedestrian and then zebra, and this actually can be tested by writing a very simple script to see whether there's a certain percentage of overlapping areas, overlapping between the pedestrian annotation and the zebra crossing. So this kind of unit test reduce the amount of errors and enhance the quality automatically. And in the future, this kind of unit test can actually becomes the requirements for training the new annotator. So think of it as like a database of tests that we apply. So for example, we create a bunch of tests, and then new annotator, when they come in, right, they need to be able to write or rather annotate the images so that it passed all the tests. And together with our development of requirements, right, we believe that if we keep a backlog of tests sufficiently large, sufficient, we will be able to enhance the quality of annotations. And this has been helping us a lot in our process of annotating for projects like in autonomous vehicles or medicals and other applications. Yeah. So in summaries, well, there are 3 problems that affect data quality for ML training. There are more, but we realize that this is a problem that current tools are currently not supporting. So no requirement feedback loop, disruptive requirement changes, loose data quality review process, and I suggested several ways to improve that. So thank you for your time. Thank you for listening. We are Ling AI. Visit our booth. Thank you.
마지막 강연이 이걸로 끝났습니다. 오랜 시간 함께 해주신 여러분, 마지막까지 함께 해주신 여러분들께 진심으로 감사 말씀드립니다. 금일 더 굿 AI can do를 주제로 진행된 AWC 2022인 부산의 모든 세션이 여러분의 뜨거운 관심과 참여 속에 모두 마무리되었습니다. 4차 산업혁명 시대 그리고 새로운 미래의 혁신을 이끌어갈 인공지능 기술의 최신 트렌드를 이해하고 각종 여러 산업과의 연동 그리고 각 국가 간의 활발한 교류가 이루어질 수 있는 글로벌 컨퍼런스의 장이 되셨길 바랍니다. 저희는 앞으로도 한 발 앞서 더 많고 더 유익한 정보와 더 값진 컨퍼런스 될 수 있도록 노력하겠습니다. 이상으로 AWC 2022인 부산의 모든 순서를 마치겠습니다. 참여해주신 모든 분들께 감사드립니다. 고맙습니다.